Now, when two nonmetals, in order to meet the octet rule, they will form covalent bonds, co meaning shared and valent meaning valence electrons. And I've come up with a set of rules for writing Lewis structures for compounds involving covalent bonds. So you'll see that these involve typically two, but two or more nonmetals sharing electrons, and we'll be able to show you how when you share electrons, you will get the 8 that each of the elements wants, and we'll show you how to do that as well. So start with the octet rule. That means that we want them to have 8 electrons each. And then steps for writing Lewis structures. These are my steps. So there are other ways of doing this. As long as you get the right answer, there are many ways to do this. But this is how I'm going to do it. And what I'm going to do is I'm going to count up the total number of valence electrons. So this is step 1. I'm going to do that for the example for the carbonate ion. That's what we're going to be doing the Lewis structure for. So we've got carbonate ion. If we looked at our periodic table, we would see that each carbon atom has 4 valence electrons. There are 3 oxygens, and each oxygen has 6 valence electrons. And then we will see that there's a 2- charge on this. So in order to complete the Lewis structure correctly, we have to add 2 electrons. Electrons are negative things, and therefore, even though it's 2-, that means add 2 electrons. So then add them up, 18, 19, 20, 24. You can call them electrons or valence electrons. They're going to be the electrons that help us complete octets. Then we're going to place the least electronegative atom except hydrogen as the central atom. Hydrogen will only ever form 1 bond. Therefore, it will never be a center atom. It will always form 1 bond. To be a center atom, you have to form at least 2 bonds. Place the least electronegative atom. Okay, electronegativity trends. This is where this becomes important. So as you go to the left and down, electronegativity decreases. So if we have 2 elements, carbon and oxygen, then carbon will be less electronegative. It turns out that fluorine is the most electronegative element, oxygen is second, and chlorine and nitrogen are tied for third, which when you need them, you will have the electronegativity scores. However, what's clear from this case is that carbon is less than oxygen, less electronegative. So place the least electronegative atom as the central atom. So that means I'm going to put the oxygens around it. That's step 2. Connect atoms by single bond. Each bond is 2 shared electrons. So I'll rewrite where I left off in step 2. Now step 3 is going to be to have single bonds. Each bond is 2 shared electrons. Each bond is a dash. Or a hyphen or whatever, it's a line. And the way that I do it is that, remember, we started with 24 valence electrons to put into this. I do not think of the electrons as belonging to any of the 1 atoms. I think they belong to the molecule. So step 4 says, sprinkle remaining valence electrons around the outside atoms first to complete octets. Well, here's where we were before. Now I have 2, 4, 6. I'm going to do 2 more for 8, 10, 12. This oxygen on the left now has an octet. I have a total of 12 electrons in my Lewis structure. 14, 16, 18. Now we have an octet down for this oxygen. 20, 22, 24. And a key part of Lewis structures is you can only put the exact number of valence electrons in the compound. So we have only 24 valence electrons. And what we can see is that carbon, the center atom, does not have an octet. That's okay. We have more steps here. We do want everybody to have an octet by the end because the octet rule rules. However, another thing that is very important, I don't know, maybe it rules too, is that you only use the same number of valence electrons that you have available. Okay, so now we're done with step 4. I imagine that I'm sprinkling the electrons around the outside atoms because, again, the electrons don't belong. We did count them up from individual atoms at the beginning, but then I think it's best to just assume that all of the electrons belong to the molecule, or in this case, ion. Now, for step 5, make double or triple bonds as needed to complete octets. I'll write in blue where step 4 left off. Okay, so that's where we left off. Now, we need carbon as the center atom to have an octet. It only has 1, 2, 3 bonds. Each bond is 2 shared electrons, so that's 2, 4, 6 electrons around it. So what we're going to do is we're going to form 1 double bond. And it doesn't matter which one you choose, and we'll talk more about that when we talk about resonance in a later part of the lecture outline 10. But just choose one. It doesn't matter which one for now. And that arrow signifies moving these 2 electrons to be a double bond. And I like to keep track of where the electrons came from, but again, as long as the correct number of electrons are around each atom, we're going to be fine. And now what we're going to do is we're going to look for octets. We get to count shared electrons get counted for both atoms or for each atom. For both atoms. So if we look at this oxygen, we have 2, 4, 6, 8 electrons around it. If we look at this oxygen, we have 1 bond, which is 2, 4, 6, 8. That is an octet. 2, 4, 6, 8. Octet over here. And the central carbon, 2, 4, 6, 8 there. And so everybody has an octet. That's what you're shooting for with the Lewis structure. And we've arrived there. That's step 5. Now, since this is an ion, we do have to do step 6. It says place square brackets if it's an ion. I'll do that part in blue. So square brackets look like the same kind of brackets that you would use for molarity concentration. And 2 minus up here. And so in square brackets, this Lewis structure with the 2 minus is our final answer. So